Out there in the quiet darkness beyond our solar system, a world is moving across the face of a distant star. We cannot see its oceans. We cannot see its continents. We cannot even see its clouds directly. And yet, somehow, scientists on Earth have detected chemicals in its sky that on our planet are made by living things. This is not a science fiction story. This is a real planet, and NASA is watching it very closely. And if you enjoy calm, evidence-based journeys into the universe, consider subscribing to Dr. Malcolm. Every week, we follow the discoveries that quietly reshape humanity's understanding of its place in the cosmos. The planet is called K2-18b. It orbits a small red dwarf star about 120 light-years away in the constellation Leo. 120 light-years might sound impossibly far, and it is, but in cosmic terms, it's practically our neighborhood. Our galaxy is over 100,000 light-years across. K2-18b is relatively close. This world was first discovered in 2015 using data from NASA's Kepler Space Telescope during its extended K2 mission, which is where its name comes from. But what makes K2-18b special isn't just that it exists, it's what kind of planet it is. K2-18b is about 2.6 times the size of Earth and roughly 8 to 9 times more massive. That means it's not a rocky Earth-like planet, but it's also not a gas giant like Jupiter. Instead, astronomers classify it as a sub-Neptune. For years, sub-Neptunes were a mystery. We don't have one in our solar system. We had no direct example to study up close, but K2-18b quickly became one of the most fascinating because it sits inside its star's habitable zone, the region where temperatures could allow liquid water to exist, and that alone already makes astronomers pay attention. But then something much more interesting happened. To understand why scientists care so much about this planet, we need to understand how they study worlds they cannot see. When a planet passes in front of its star, a transit, a tiny fraction of starlight, passes through the planet's atmosphere before reaching Earth. That atmosphere leaves a fingerprint in the light. Different molecules absorb specific colors of light. So by analyzing the starlight very carefully, astronomers can determine what gases are present in the air of a planet over 1 trillion kilometers away. And this is where the James Webb Space Telescope changed everything. Launched in 2021, Webb is not just a bigger Hubble. It observes infrared light with extraordinary sensitivity. It is, quite literally, the most powerful instrument ever built for studying the alien atmospheres. When Webb turned toward K2-18b, scientists weren't expecting certainty, they were expecting clues. They got them. Webb detected strong evidence of carbon dioxide and methane in the atmosphere. Now, those gases by themselves don't mean life. Volcanoes and chemistry can produce them. But their presence tells us something very important. It suggests the planet has a hydrogen-rich atmosphere over what may be a deep global ocean. This has led scientists to propose that K2-18b might belong to a new category of world called a Hycean planet, short for hydrogen ocean. Imagine a planet larger than Earth, wrapped in a thick atmosphere, with a warm ocean stretching across the entire globe beneath a hazy sky. Not Earth-like, but possibly habitable. And then came the most intriguing observation. Webb found a tentative signal of a molecule called dimethyl sulfide, or DMS. On Earth, DMS is almost exclusively produced by life, specifically microscopic marine organisms like phytoplankton. To be clear, scientists have not confirmed life on K2-18b. The signal is weak, it needs more observations. But the reason astronomers became so interested is simple. We did not search for this molecule, it appeared in the data. So what are biosignature gases? A biosignature gas is a chemical in a planet's atmosphere that could indicate biological activity. Think of them as indirect fingerprints of life. Oxygen on Earth is a classic example. Without plants and microbes, oxygen would quickly react with rocks and disappear. Its continued presence requires constant replenishment, which life provides. Methane can also be biological, although it has non-biological sources too. Carbon dioxide is common, but important because it helps regulate climate. However, certain combinations of gases together, especially ones that shouldn't easily coexist, can suggest something unusual is happening. Dimethyl sulfide is different. There are currently no widely accepted non-biological processes known to produce large quantities of DMS in a planetary atmosphere like this. That is why K2-18b matters. Not because scientists found aliens, but because they may have found a chemical imbalance that begs for explanation. However, science moves carefully. Astronomers are cautious for a reason. History. Over the past century, we have had many possible signs of life. Martian canals in the 1800s, microfossils in meteorites in the 1990s, methane plumes on Mars in the 2000s, phosphine on Venus in 2020. Each time, excitement surged, and each time, alternative explanations emerged. Nature is very good at imitating biology. Chemistry in extreme environments can produce surprising molecules. Instruments can introduce noise. Data can be misinterpreted. So scientists studying K2-18b are openly skeptical even of their own discovery. The dimethyl sulfide detection is currently considered tentative. It needs repeated measurements, stronger signals, and independent verification. There may be unknown chemical reactions happening in hydrogen-rich atmospheres that we simply don't yet understand, and that honesty is exactly why this discovery is important. This isn't a press conference announcing extraterrestrials. This is a careful, methodical investigation. What makes K2-18b different from past claims is not the excitement, it's the method. For the first time in history, we have a telescope capable of repeatedly analyzing the atmosphere of a potentially habitable planet and searching for multiple gases at once, not one molecule, an atmospheric pattern. Science doesn't rely on a single clue, it relies on converging evidence. And K2-18b is one of the first places where that might actually be possible. So what happens next? The James Webb Space Telescope will continue observing the planet during future transits. Each pass improves the data, reducing noise and strengthening or weakening the DMS signal. Scientists are also building atmospheric models, testing whether purely chemical processes could reproduce what Webb sees. Future telescopes like the upcoming extremely large ground-based observatories will study it as well. Over the next decade, K2-18b will likely become one of the most observed exoplanets in history. Because if the signal persists, if methane, carbon dioxide, and dimethyl sulfide are confirmed together, then scientists will face a profound question: what process is maintaining that atmosphere? And biology would become a serious possibility. Imagine that for a moment. Not intelligent civilizations, not spaceships, just life, perhaps microscopic organisms, drifting in a warm, alien ocean beneath an orange star. Simple life would still change everything. For all of human history, we have wondered whether biology is a cosmic accident, something that happened only once, or whether the universe naturally produces it wherever conditions allow. K2-18b may help answer that. And if life exists there, it would mean the universe is not silent. It would mean that biology is not unique to Earth. It would mean we are part of a larger living cosmos. At the beginning of this century, finding life beyond Earth felt distant, a dream for future generations. Now, for the first time, we are not searching blindly. We are examining a specific world with a specific atmosphere for specific chemical fingerprints. And NASA is watching carefully, quietly, patiently. If you want to follow discoveries like this as they unfold in real time, subscribe to Dr. Malcolm. The next decade of astronomy may answer one of the oldest questions humanity has ever asked. Are we alone? Somewhere, 120 light years away, a small planet circles a dim red star, and inside the thin glow of its atmosphere, a mystery is waiting to be understood.